Well, hello. Good to see you again. Or maybe I should say good to be seen by you again, since I probably can't see you. This particular video, I'm going to describe a little bit more about what we can find on the periodic table. And I'm going to be using one of my favorite online periodic tables, but most periodic tables have similar information. So I'm going to be toggling back and forth between the online periodic table and drawing on this page here, so that you will be able to better use the periodic table yourself. So let's first take a look at one of the boxes on the periodic table that we're going to kind of use to dig into a little bit more detail. Okay, so here's the P-table version of the periodic table, and this, I want to point out, is not the image. Previously I had used just an image because it left a lot of the clutter out, but now I need some of these important details. And obviously with 100 and some little boxes, it's a little hard to see the detail. So I want you to notice that as you click on a box, that up here in the upper left corner, it will show you the detail in that box. Otherwise you got to zoom way in. So I'm going to go over here to sulfur, and I don't pick sulfur for any particular reason other than it makes a good example for what I want to show you. And I'm going to try to describe what some of these other numbers are that we haven't been through. I'm going to draw this on my paper in just a second. But while we're here, let me point out something that we've already seen. The most important number for sulfur is this number here, and this is true for any element. It's the atomic number for that particular element. So all the atoms of sulfur have an atomic number of 16, which means they have 16 protons in the nucleus. Now there are different kinds of sulfur atoms that have different numbers of neutrons. So this periodic table, or any periodic table, cannot tell you how many neutrons a particular atom has. So don't expect to find that. Now some will mistakenly think that it's related to this 32.06 number. That actually is just the average mass of all the different kinds of sulfur that exists in the world. So you can't tell anything about a particular atom just based on what we call the atomic weight down here. So just forget about that number for now. When you're in a more advanced chemistry class, you're going to use that and figure more stuff about sulfur. But for now, we're just going to pay attention to the 16 atomic number, because that gets us the protons. And here's what we're going to focus on today. It's these three numbers here, 2, 8, 6. So let me draw this on our paper, and you can draw what I'm going to draw here too, and then we'll dig into what we're actually seeing, what those numbers mean. So back here in your notes, let's just draw a little model of what we saw here. So a nice prominent S, and we call that the symbol. And every element has a symbol because you don't want to write out the full word, especially some of the really bigger named elements. And then we saw in the corner 16. Now some periodic tables will put the atomic number down below it. It doesn't matter. You're always going to be able to tell because it will be the whole number, and it will be the number that you count up by each time you go over to the right on the periodic table. Okay, it's just like reading a book. Okay, so just a reminder here that that's the atomic number. Okay, and I will go ahead. Not every periodic table has the name written, because when you study a lot of chemistry, you just get used to using the symbols more. But you're early on into this. I wouldn't expect you to recognize the symbols. So you'll have to do a little hunting maybe to relate the symbols with the names. But here's what we want to focus on today. The 2, the 8, and the 6. The importance of these numbers here is that they show the locations of the electrons. So we really haven't focused on electrons before. The last lesson was more about protons and neutrons and mass number, etc. But remember, something we went through before when we were talking about the Bohr model of the atom, is that we visualize these electrons as being located in energy levels, kind of like orbits around the nucleus. And I had to show you that there are certain numbers of electrons that fit, if you will, inside these different energy levels. And you can't put more than what will fit in there. So the first energy level, for example, can only hold 2. And if you have more electrons to put into your atom than 2, you have to go out to the second energy level, which can hold 8. And then if you have more electrons beyond 10, then you have to go out to the third energy level. And we can have over 100 electrons. So where are those things going to go? It gets a little messy, but these numbers kind of give away where those electrons are. So for example, for sulfur, oops, almost misspelled it there. Just ignore that at the end. So there are 2 electrons in the first energy level. That's the 2 at the top. And there are 8 electrons in the second energy level. And there are 6 electrons in the third energy level. 2, 8, 6. Take a second to jot that down. And let's look at the total here. So 2 plus 8 plus 6. That adds up to 16. Do you remember this, something I had mentioned earlier? The number of electrons in a typical atom matches the number of protons. And this, remember, is the number of protons. So when you add up these numbers here, you will always add up to the same number as the atomic number. Okay? So how would we draw this atom? Remember we drew Bohr models a couple lessons ago. So let's use these numbers here to be able to represent it. So we're going to leave ourselves some space. That'll be our nucleus. Now again, I cannot tell for this example what's inside the nucleus because I haven't said anything about which kind of sulfur we're drawing, what we call the isotope of sulfur. So we'll just say that represents the nucleus. And we know it has 16 protons and some number of neutrons. But when we're drawing the Bohr model, we're usually not all that concerned. Here's the first energy level. We kind of draw it as far away from the nucleus as is convenient. We don't want it to be huge, obviously, but we don't also want it right up close to there. So we'll have 2 electrons there. Again, up to you. Different teachers have different styles for how they like these dots drawn. But those represent those 2 electrons there. And then a little further out from that, let's draw the best circle you can. That's the second energy level, and it's going to have 8 in it. Make them nice and prominent. When I was looking at your drawings before, I remember some of them were easier to see than others because you had nice dark drawings. Makes it real easy for you to see this on video, doesn't it? So that's 10 out of the 16 electrons. So we got 6 more to place. And so that's why we have 6 out in the third. I'm just going to put them here, close by the ones from the second energy level, but I'm only going to put 6 there, not 8. And so that's a good representation of the Bohr model for an atom of sulfur. Pause it here if you need. Okay, so let's go back to the periodic table, and I want to show you a really neat pattern that's on there that's going to make this kind of connection really simple. So back to the periodic table. Here we go. So I want you to notice the numbers across the left side and across the top. Okay? So the first thing I'll point out is the numbers here on the left. They're numbered 1 through 7. And I want you to keep in mind that these 2 rows down here are not rows 8 and 9. They are actually part of rows 6 and 7. They just didn't fit very nicely, and so they moved them out of the way so that we could squeeze everything a little bit more compactly. We went through that the first time we saw the table. But these numbers here, and I'll write this in the notes in just a second, they're referred to as the period numbers or the horizontal row numbers. And they tell you something really important. For example, notice my sulfur atom is here in that row, horizontal row 3, and every element in that row has 3 numbers for its energy level. So starting here with Na or sodium, you see how it has 281, that's 3 digits. Magnesium is 282. Over here, aluminum, 283, 284, and all the way over to argon, 288. Every one of those elements has 3 numbers, which means it has 3 energy levels in which elements, or in which electrons are located. Okay? But when we go down to the 4th horizontal row, now we have 2881. We have a new energy level with an electron in it, starting with K, or potassium, and all the way across that row you will see the elements have 4 digits. That means 4 energy levels that have electrons occupying them. Okay? So let's summarize that back in the notes. Take a new page here. Here we go. So we'll say it this way. For any element its horizontal row on the periodic table, which I will abbreviate PT, I hope that's okay, is called its period. That's where we get the name periodic. Its period number. It shows how many energy levels have electrons occupying them. Okay. Really important to know the period. That's sort of the definition of what a period means. So that's a nice little shortcut. Again, you can pause if you need to catch up on the writing. Nice little shortcut. If I say, give you the name of any atom, and I'll say, how many energy levels would the electrons occupy for this particular atom? You don't have to try to count. In fact, you don't even need a periodic table that has all of that detail in there. Okay? Let me show you an example. I could click, for example, I clicked on bromine there, and I could see 4. But, if I asked you about, let's say, tungsten, which has the odd symbol W here. And if I say, how many energy levels would its electrons occupy? You don't need to click on it and count those numbers. You can just go over here to the left and see that it is in period 6. And it would have, therefore, 6 energy levels. Okay? The first one's all filled up, and then it makes its way out to the 6th one for its final electrons. All right? So that's a nice little shortcut. Let's look at another shortcut. And this has to do with the vertical column that it's in. We call that the group or family number. So back to our first example, which was sulfur. Notice that sulfur has 6 outer electrons. That's the outermost energy level, the 3rd one, and how many electrons are there. So we call those the outer electrons. Well, it has 6, and if you look at oxygen just above it, it also has 6 in its outermost energy level. And right below it is selenium. It has 6. And every element in that the 16th column has the same number of outer electrons. There's a nice little link there. Let's look at the column next to it. The nitrogen group, or the nitrogen family, it has 5 outer electrons. And we go down to phosphorus just below it, also has 5. And so that is something that's very common to all of the elements that are in a particular vertical column, known as the group. Okay? So let's write that in a nice way that you can remember. All right. An element's vertical column now, again, sometimes people get mixed up. Vertical is up and down. Horizontal is like the horizon when the sun comes up, and that's left and right. I will try to be real careful to use the word column. Columns are like what hold up roofs on some houses. They're also vertical. Okay, you would never say a horizontal column because that would be kind of a mix-up. Like horizontal goes this way, columns go up and down. So the vertical column is called its group or family. Group or family number. And it shows how many electrons occupy the outermost energy level. Okay, very important. Outermost energy level. You'll hear this word as well. I wasn't sure if I wanted to introduce it today, but I think I will. That outermost energy level is often called the valence energy level. So when you hear of valence electrons, those are the ones in the outermost energy level, farthest away from the nucleus. Okay? Again, pause here if you need to. If you get caught up on any writing, maybe underline those key words. Those are like vocab words that in a textbook would be highlighted or underlined or something. Now we have kind of some funny business here. Let me go back to the periodic table and show you. It's a little frustrating. But there are 18 groups. That's 18 vertical columns. But when you go across it, I want you to look at the outermost energy level. I'll just start here with potassium. See, it has 1, and so it's in group 1. Calcium next to it has 2 outer electrons, and so it's in group 2. But the next 10 columns, from 3 through 12, they do not follow the pattern. So going over, we have 2, and then 2, and then 2, and then 1, and 2, and 2, and 2, and 2, and 1, and 2. So there's no pattern there. But we do pick up the pattern here in column 13. Group 13 elements all have 3 outer electrons. And then the 14th column has 4. 15th column has 5, and so on, all the way over to the 18th column. And we will never have more than 8. Okay? So let me summarize that in a little table for you that might help. So I'll put group number, and this is the last thing we're going to do, and outer electrons. Again, these are often called valence electrons. I want you to know that word. So 1, 2, 3, whoops. 1, 2, and then 13, 14, 15, 16, 17, and 18. I'm skipping 3 through 12 because they just don't follow a pattern. Okay? So there's 1, 2, 3, 4, 5, 6, 7, and 8. Like that. All right? So we can always figure out what an atom's electron arrangement is like in those energy levels just by looking at what horizontal row it's located in, or the period, and what vertical column it's in, called the group. Okay? All right, so we'll stop here, do a little practice with this, and see if you can kind of get the hang of it.